Okay, today's lesson is lesson 3-3, addition and subtraction equations. You need to open up your book and have your notebook out to take notes to page 98. So this lesson is solving algebra equations, doing the proper algebra while doing it. When you were in elementary school, you were solving equations like this, but you didn't have to follow this correct format. In 7th grade math and in math in general, we know that two equations are equivalent. Equivalent means equal to. If they have the same solution, which means that they have both sides are equivalent or equal. There are two properties that we're going to use to solve these types of problems. The first one is the addition property of equality, which says that adding the same number to each side of an equation produces an equivalent equation. So whatever you do, if you add a number to one side and add a number to the other side, you're going to have an equal answer. Because you did it to both sides, it still remains equal. And then there's the subtraction property of equality, which says the same thing, except that this time you can subtract the same number from both sides and it'll still remain equal. Now, when you're solving a balanced equation, or when you're solving an equation, you need to think of it like a pan balance. Or I often like to say, think of it like a teeter-totter. If this is the base of your teeter-totter, whatever you do to one side, you need to do to the other. And if you do that same thing to both sides, your equation will remain equal. That's what makes it legal or proper in math. Okay, so whatever you do to one side, you have to do to the other. That is referred to often as balanced equations and inverse operations. And we're going to use balanced equations and inverse operations a lot. And in 7th grade math, you're going to use it in 8th grade math, and you'll use it in algebra. That is the process that you're going to use in which to solve your equations. And that work that you're going to do shows those equivalent equations by doing balanced equations and inverse operations. To solve an equation, you're going to do the inverse operation. The inverse operation means the opposite to solve your equation. So if your equation has addition, x plus 2 equals 10, you're going to do subtraction, because the opposite of addition is subtraction and the opposite of subtraction is addition. So that's what inverse means, doing the opposite to solve. So you'll add the opposite to both sides to get that variable alone. Okay? Let's see. Balanced, or in inverse. The inverse means you need to do the inverse operation to get that variable alone, which is what I just said. The goal in algebra is to get that variable alone. That's huge. That is what you're trying to do anytime you're solving an algebraic equation, is you need to get that variable alone. Okay, so this vocabulary is extremely important, so make sure that you are familiar with these terms, because these are terms that I'm going to use all the time. Balanced equations and inverse operations. Balanced meaning you do it to both sides. Inverse meaning you do the opposite to solve it. So if you're adding, you're going to subtract. If you're subtracting, you're going to add. And then always think of it like a teeter-totter, and wherever the equal sign is in the equation is like the base of that teeter-totter, and whatever you do to the side to the left or to the right, you have to do to the other. Okay. So if I have an equation, x minus 5 equals negative 1, I would rewrite this equation to x plus a negative 5 equals negative 1 to eliminate that subtraction sign. And I would strongly recommend that you do that, although with simple equations like this, it isn't that important, but I still do it. And then you're going to add, or subtract, because we're adding the opposite, is subtract the opposite. Well, what you would notice is if you're subtracting a negative 5, that's the same thing as adding 5. So this is the thing. In your algebra tile activity, when we were balancing your equation with the algebra tiles, we couldn't subtract. So we added the opposite. Adding the opposite is the same thing as subtracting. So anytime you're subtracting, I am going to say add the opposite, or add the opposite to solve, because that will give you your answer. And it matches with the algebra tiles, although adding 5 is the same thing as subtracting a negative 5. Remember that where that equal sign, that is your balance, your teeter-totter base, okay? And then you need to have this long equal bar, okay? Because this essentially turns your problem into two different problems. One on the right, you go from a horizontal problem to a vertical problem. One on the right, going vertical, and then one on the left, going vertical. And then you solve it. On the left, you have x plus a negative 5 plus 5. That is equivalent to x, because that negative 5 and that positive 5 cancel out, and you're left with x, because those are like a zero pair. Okay? Then you have a negative 1 plus 5 on the right, and when you have a negative 1 plus 5, you end up with 4. Now, if you're going to check it, you take that 4 and you plunk it back in for that x, which I would strongly recommend that you do. And if you do, this should all work out. Okay? Now, these problems are going to be worth multiple points. So even if you wrote down the answer, x equals 4, that's correct. But you're going to lose points because you didn't show all that work. So you need to make sure you show all that work. In 7th grade math, you are not good enough yet to eliminate that work. Okay, even in algebra, they're going to expect you to show that work. Now, you can do these problems horizontally or vertically, which would mean that you could write plus 5 on each side here of the variable and not go vertical. But I really do prefer you doing vertical. It just is, everything has its place. It's just easier to see, especially when a person is checking for your work. Okay. Everything in green here you have to do, but this triangle base, you do not. Okay? That's the only thing you would be allowed to eliminate. I just put that there to show you what that means, what that balance means. Okay. I would like you to pause your computer, and I would like you to do number 1 for me. And then when you're done, come back and we'll check it. Okay. So number 1 is p minus 5 equals negative 2. So I would rewrite that as p plus a negative 5 equals negative 2. And then because we're adding a negative 5, we need to add the opposite. So adding the opposite means that you're going to add 5, because the opposite of negative 5 is a positive 5. And then you put a long equal bar, and you end up with p equaling 3. And then you can plunk in that 3 in for p to check it, and you will see that you have the right answer. Okay, example 2. Example 2 is using a word problem and then creating an algebraic equation and then solving it. So in this problem, they have a company has a profit of $750 this week. This profit is $900 more than the profit P last week. Which equation can be used to find P? So here you would write the equation 750 equals P plus 900. Okay? And then you could solve that by doing the opposite. So you would subtract 900 or add a negative 900 to both sides. So if this was my equation, I'm recording, you would add a negative 900 to both sides, and you end up with P equaling a negative 150. Okay? All right. Dollars. I would like you to pause your computer and do number 4. Write an algebraic equation for this situation, and then solve it using balanced equations and inverse operations. And when you're done, you can pause your computer or pause your computer, do this, and then when you're done, come back and we'll see how you do. Okay? All right. So the equation is 120. The company has a profit of $120.50 today. The profit is $145.25 less than the profit yesterday. Write an equation that can be used for P, and I want you to solve it. So you have 120 equals P minus 145.25. Now I turned it into plus a negative because that's what Mrs. Shaw does. And then I'm going to add the opposite. So I'm going to add a positive 145.25 to both sides. And I'm going to end up then with P equaling on this side the negative 145.25 and the positive 125.45 cancel out. And on the left, you're left with $265.75. And that would be your answer. If you answered that right, you can move on. If you made a mistake, I need you to rewatch this portion of the video to make sure that you understand it. Okay, then we have another section where you're dealing with a real-life situation, a word problem, and you are having to change that word problem into an algebraic equation, and then you're going to solve it, just like we did before. Okay? So I want you to do number 5. I want you to do number 5. Pause your computer and let's watch number 5. Okay, so if I have x equals, first you should define your variable. So like up here in the example, they told you what x equals. Okay, it said that your friend's score is 33 points less than your score, so you would let s be your score. Whenever choosing a variable, it's nice if you can pick a letter that's similar to, or like what you're talking about. So here s equals score, although I don't like using s because s can look like a 5, but you know, you just have to be careful how you write it. So if we're talking about friends, you can have f equals friends, or if you're talking about apples, a equals apples. Sometimes when you define your variable, sometimes it's nice to just keep the letter like what you're talking about. Or you could be like me where you like to use x all the time, which is what Mrs. Shaw likes. So in this case, the problem, if you have negative 12 points after level 1, your score is 27 points less your friend's score. What is your friend's score? X equals your friend's score. You should define your variable for every single problem. And if you don't define your variable, you're going to lose a point. I want to know what x is. What does x represent in your equation? Because that is also going to help you with determining what your label is. Okay? Okay, so in this equation, you have a negative 12 points, and that equals x, x plus a negative 27. Okay? Now, I changed it to plus a negative. It is truly minus 27. And you can write it like that. I just choose to always change it. It's not necessary, but it's what I like to do. We needed a drink. Okay. So, if I'm going to solve that, I'm going to add the opposite to both sides. So I'm going to add 27 to both sides. And I end up with, on the right, a negative 27 and a positive 27 is going to give me just x. And on the left, a negative 12 plus 27 is going to give me 15 points. Okay? If you got anything wrong here, you need to rewatch your video, please do so. Because a problem like this is going to be worth 1 point for defining your variable, 1 point for writing the equation, 1 point for showing the balanced equations, 1 point for the answer, and then a point for everything else. So you're looking at like 4 or 5 points for problem number 5, for a problem like problem number 5. So you want to make sure that you show everything, because just getting that answer isn't going to be enough. I need to be able to follow your thinking while you're doing it. So it needs to be neat so that I can understand it and that I can follow it. If it's not neat, you're going to struggle. Okay, so make sure that it's neat. Okay, so what I want you to do now for tomorrow is I would like you to do number 5 and number 15 for tomorrow. Come back and have number 5 and number 15 done on page 100. Okay, and then we'll go through those when you come back to class. Remember, the key or the thing that you're doing is you're making sure that your equation stays in balance by whatever you do to one side, you do to the other side, and you're going to solve by using the inverse, the opposite expression, the opposite of what you're doing, okay? Adding the opposite or subtracting the opposite, okay? Okay, make sure you have all of these notes written down because these notes are extremely important. Okay, I will see you tomorrow.